What we're going to talk about now is single completion stage methods. So these are the methods that are going to be triggered when a single previous stage completes. And we'll start with then apply. And the then apply method is going to be passed a function, and it will apply the action of that function when the previous stage's results are done. So when the computation finishes, then this function will be applied to the results of the previous stage. Then apply returns a future that contains the results of applying the action, which, of course, as you see, may take a while to percolate if the action takes a while to run. You typically use then apply for a so-called synchronous action or a sync action that returns a value and does not return a future. So what's an example? This is based on the example we saw before, where we create a unreduced big fraction. We then create a supplier called reduce that, when called, will reduce the unreduced fraction. And then after supply async returns a completable future to the results of reducing the big fraction, then apply will be triggered when supply async returns, and this will then return a string value. And of course, then apply actually returns a completable future, but it'll be a completable future to a string that will be generated when this action is applied. Okay, so typically we use then apply for things that will just do something usually fairly quickly, and we don't have to worry about having them run in the background for very long. A much more interesting method is the then compose method. And as you can see, then compose takes a function also, and as with then apply, this function action will be applied when the previous stage results are done. So when the future is triggered from the previous stage, this function action will be applied. And what this does is this returns a future containing the results of the action directly rather than a nested future. So what the heck does that mean? So I'll first give you a little analogy, which may or may not be helpful to you if you know other parts of Java, and then I'll show you the example in more detail. So then compose is a bit like flat map, or a bit like a flat map on a stream or flat map on an optional, in that it goes ahead and de-nests things. So what happens when you use this is you end up getting back a completable future to one result directly versus nested completable futures, which is what you would get if you used then apply. So let's take a look at an example that will hopefully make this a little bit more clear. It's a little bit mysterious at first, and it takes some while to get your head around it. So you use then compose for asynchronous actions that return completable futures. So remember, we used then apply for synchronous actions that returned a value and not a future. We can then use then compose for async actions that return a completable future, but we want those completable futures to be de-nested. So let's take a look at an example. Here's an example where we're going to create ourselves a function which is called reduce and multiply fractions. A bit of a mouthful, but that's what it's called. And you can see that this is going to take a big fraction, which I abbreviated just because it was getting too large, and then a completable future to a big fraction. So it's going to take a big fraction, and it's going to return a completable future to a big fraction. That's what reduce and multiply fractions is doing. And you can see it takes an unreduced input, calls supply async, and reduces the unreduced input, the unreduced fraction, big fraction. So this supply async call is going to return a completable future to a big fraction. Okay, so far so good. Then what we're going to do is we're going to compose the results of this so that then compose is called when the computation provided to supply async completes. So this thing is going to complete, obviously, when we reduce the big fraction, in which case then compose is going to be called. And look what then compose does. Then compose itself is going to call supply async. And remember, supply async runs asynchronously, or rather it sets something up to run asynchronously, and it will go ahead and schedule the computation supplied to it, which is going to multiply the reduced big fraction that we just got as a result of the asynchronous supply sync call completing with whatever parameter we pass to multiply. And supply async also returns a future, completable future, but then compose is going to denest this future to only return a single completable future to a big fraction. Well, you're still probably going like, what the heck is going on here? And the reason we're doing then compose here instead of then apply is because if we used then apply with the same call, we would end up with a completable future to a completable future. So you can see that then apply returns a completable future that is not de-nested. And so we would end up with this doubly nested completable future, which works, but boy, does it get ugly and it doesn't compose well, which is why there's then compose, which does de-nesting. Now, there's actually another way to do this, which gets the same result and avoids some of this complexity. There's also an async variant of then apply. And the async variant of then apply will cause its parameter to run in a different thread in the background in the worker thread pool, whatever worker thread pool is associated. In this case, it's a common form join pool. So you can either use then apply async and have this thing run in the background, which will then also just return a completable future, but it will run in the background. Or you could use the horrible then apply without the async variant, which would then have to be told to run asynchronously if you wanted it to run asynchronously, but then you'd end up with too many nested completable futures. Or you could use then compose with supply async. So what we want here is to have a single completable future. So you either need to use then compose with an asynchronous generated completable future to denest it, or you could use then apply async, have that run in the background, and also end up with a denested result. Both approaches work. I'm kind of a fan, honestly, of then apply async, but either approach works. Logan. You use then apply if the computations, as we had talked about over here, you use then apply when you have a synchronous action that returns a value, not a completable future. So something like toMix string, that just returns a value, it returns a string, it's not going to run asynchronously, you don't need to have it run in the background thread. That's when you would use then apply. So use then apply if the computations aren't going to take long to run, they run synchronously, and that's not a big deal. Okay, so you could also do some funky things with then compose. You could run something in the background. Let's say it's going to run for a long time and get back to completable future. And then we can call then compose and give function identity. And that will also flatten out the results to avoid nested completable futures. Both approaches work. You could also do this. You could say then compose async and then return something that runs for a long time as a completable future. That will also run in the background. And you can use then compose async to avoid calling supply async again in the chain. Notice over here we used supply async here to get this to run asynchronously and denest. And over here we could use then compose async. Okay, so that's pretty subtle, and you'll get a chance to play around with then compose and then apply in assignment number 4. The next method is then accept, and this is quite simple, but it also has some sinister dimensions to it. Then accept takes a consumer action, and when the previous stage completes, it will apply the action to the result from the previous stage. And basically, this action behaves as a callback with a side effect. So as you'll see, there's a callback-like behavior that has some kind of side effect because, as you can see, it doesn't return a value. So then accept does not return a value. It returns void, which means there's no value returned. You get a completable future back, which you could join on, for example, but you can't actually get a result. So here's a simple example of using then except. This is in the same spirit of our previous example, so I won't go through and walk through all the stuff in detail, but you typically would use then except at the very end of a chain of completion stages when you just want to do some operation that has a side effect. So you can see here that we go ahead and run this asynchronously. We then turn the result to a mixed string, and then we accept it and we call system out, and that goes ahead and prints the results out after it gets back the result from then apply, after the then apply completable future triggers when it's done. Now, so this approach works pretty well if you limit yourself to using then except only at the end of a chain of completion stages. If you don't do that, if you use then except all over the place, you end up with something known as callback hell, which is what we can run into if we're using JavaScript, where you don't have all these other super cool features that Java CompletableFutures has. And so you'll end up writing, a hideous code like this that ends up very nested. It's like, what was the point of that, right? Very complicated. So we want to avoid callback hell if we possibly can. So limit your use of then except for examples like I just showed you. So that's the end of the discussion of the single stage completion methods. And I think you'll agree those are the most numerous of the different examples.